So 36 divided by 90 multiplied by 42. 16.8. And in this case also 36 divided by 90 multiplied by 18, 7.2. Now here we go. 36 divided by 90. 36 divided by 90, the total, and multiplied by 30, which is 12. Everybody following what I'm doing? Okay. Now we do this for the last one, and the last one will again be the same thing. You take each of these values, the column, the row, 33, divided by 90, multiplied by the appropriate column. In this case, it would be, let's say, 42 in this case. Start out with 42. 33 divided by 90 row. So let's do that. 33 divided by 90. Multiplied by 42 gives us a 15.4. 6.6. Okay, let me make sure that everybody got all of that. So it's a formula in which you basically are trying to calculate the expected value based on the what you see in the column, the total of the column, in relation to the total in your row in relation with your column. So since community A is the biggest community, it's the biggest community, right? It has 42 people. The division here should be really should have bigger numbers than these numbers, and you can see they're bigger numbers because there are more people in community A than in community B and C. But the distribution of these numbers will totally depend on what the final results of their polls are, whether for or against or neutral, right? And most people seems to be against, right? So most people here will be against. So you can see most people in this case are against. The next choice is neutral, and that's this number. And fewer people are for. And similarly, you'll find the same distribution here. Most people are against. Fewer people are neutral. And then the fewest are for. And so it's distributed. So you find your expected based on a proportion of the values, the total row values, in relation to the, how many people you have in each community, or your column values. So that's what the formula is all about. It's finding a proportion of people, using these proportions. These, you can think of them as proportions. You know, this is the lowest, this is the highest proportion. So you want to distribute these proportions in these cells in relation to the size of each of these groups. Does that make sense? Everybody got that? Should I repeat it? How confusing is this? OK, so you've got it. Now, if it might require you to see it or do it a few times. But after you've gotten this, this is all you need. This is what you're going to get. I'm going to give you a problem exactly like this on the test. And your task is to actually calculate the expected value. And after you've calculated the expected value using this formula, so you'd use this formula here. After you've done that, you basically do what we just did, which is use the chi-square formula. And the chi-square is as follows. Chi-square is equal to the sum of the observed minus expected squared over expected, right? So you need to go through the process of calculating that for all of these cells, and you add them together. OK, so let's do that. Let's do that together. So you start the process, and I will do it too. But go ahead and start the process. So your first observed minus expected is 12 minus 9.8 squared over 9.8. And then you add to that 6 minus 4.2 squared over 4.2. You add to that 3 minus 7 squared over 7 plus 18 minus 16.8 squared over 16.8. Three minus 7.2.
You just add everything in a whole line, everything together?
Yeah, you could do that in a whole line, yeah.
Well, that's okay. I'm making sure it wasn't like per row was different.
No, no. You basically per cell. You do it per cell.
Okay, so everything gets added up.
Exactly. Per cell, you just add all of these cells. You basically are calculating discrepancy within cell, and you're averaging them. Or you're actually just taking the sum of these discrepancies. OK, so you keep doing that. And why don't you start doing it, in fact? Here we go. I'll do it too. Sorry? It is warm, yeah. 15. So basically, this is your chi-square. So let's do the calculation.